Hello, my name is Todd Miranda, and in this video I'm going to demonstrate how to build an asynchronous progress bar in a WPF application. So let's begin in Microsoft Visual Studio 2008. We'll choose File, New Project, and we'll name our project accordingly. We're going to create a WPF application targeting the .NET Framework 3.5. So when we create our WPF application, we'll get a default window, and we'll just use our default window to get started with this. We're going to kind of build just a little bit of an interface to demonstrate how we would build a progress bar that would be part of your page, and then how you could free up the user interface using a background thread to run your process and still be able to update the progress bar in your main window. Okay, so let's begin by creating our interface, and we're going to start by creating a stack panel. And we can put in the stack panel, we'll have a couple of buttons, and our first button will be button begin, and this will actually kick off our long-running process. So content will be start long process, and then we'll have a click event, and we'll just use the new event handler shortcut and have it create that for us. Then we're going to have another button, and we'll name this button interact, and this will be a button that we'll be able to use to interact with the user interface. And we'll use this button to demonstrate how in one way we'll lock up the user interface by doing some kind of a long-running process. Then we'll fix that by doing our long-running process on a different thread, and show how we can talk from that thread back to our UI thread to update the progress bar. So we'll do content equals interact with UI, and we'll do a click, and click will be new event handler. Alright, so there's our buttons, and we're done with our stack panel. And what we'll do actually is we'll come in here and we'll just do horizontal alignment equals center on these, and that way they won't completely stretch across our stack panel. Otherwise they would stretch out to fill the entire width of the stack panel. Okay, so now we're going to create so this would be our user interface, and there's lots of ways that we can do progress bars. We can pop up another window and display the progress bar in that other window. Perhaps that's a modal window, but the point here would be the fact that maybe we still want to show a progress bar, but we still want to allow the user to interact with the user interface while that long-running process is occurring. So what we'll do is we'll split the difference, and we'll make what looks like kind of a pop-up that we'll be able to display or hide. So it'll be kind of like a pop-up window, but it'll actually be embedded in the page, and you could come up with whatever combination of that you'd like to. You might even have a section of your application where you have your progress bar and it's always visible or just shows while the application is running, and it's just a dedicated area of the application. That would be fine too. So we're going to do a border, and we'll give this a name so we can interact with it, and we'll just call this border progress. We'll do a corner radius on this of say 10. We'll do a border brush of dark gray. We'll do a border thickness of 1. We'll do our horizontal alignment equals center, and we'll do a vertical alignment equals center, and then we'll add a couple of other things to that as well. Let's also come in here, and we're going to do visibility equals hidden. Alright, and finally we'll do a background, and we'll do a background of, maybe we'll do early wood. Okay, so there's our border. One of the key points to note here is visibility equals hidden. The other things are just really kind of stylish type things that we're doing to our border. Now also note that this is in a grid, and we haven't specified any grid rows or any grid columns. So the border here is really going to, as far as the X index goes, it's going to sit in front of our stack panel, and it will sit on top of our stack panel as well. So it's important to remember that this is how we could do a progress bar that's going to be able to be shown and sit on top of some other element that's underneath it. Alright, so within our border, let's do a stack panel. And within our stack panel, let's just do a grid, margin equals 5. And the reason we're using a grid here is the same exact reason that that I was mentioning with our root element grid. And I'll show you what I'm talking about. We're going to create a progress bar. Obviously we'll name that so we can interact with it. And we'll set a width of 200, a height of 20. We'll say our min value, our minimum is 0, and our maximum is 1. So we're going to go from 0 to 1. So at 0 you won't see any of the progress bar. At 1 you'll see 100% of the progress bar. So we could go 0.1, 0.2, 0.3. This could easily be 100, and then your values would be 0, 10, 20, 30, 40, 50, that kind of thing. So we'll just go from 0 to 1. And then without specifying a row or a column, we're going to also have a text block, and that text block will have a name, text progress. So what's going to happen is this text block is actually going to sit at the same XY coordinate, which is top left 0, 0, as our progress bar, and it'll sit on top of the progress bar because it comes second in the XAML. So we're going to do a horizontal alignment of center and a vertical alignment of center, and this is going to center it within the progress bar, because the progress bar is going to set the size of the grid, because grid by default will be auto, so it will stretch and move around to fit the progress bar. The text block will sit right on top of it, and we'll close that. So that gets our progress bar and our text block. So now right up under here, still within our stack panel but outside of our grid, we're going to have a button, and you don't necessarily have to provide a cancel button. Perhaps your process is such that you're not going to allow the user to cancel that long-running process. But I want to demonstrate how you could do that. So we're going to add a cancel button, and its content will be cancel. And then we'll also do a horizontal alignment equals right. Okay, and maybe we'll do a margin of 3. So now we've got a cancel button. Again, you don't have to have a cancel button. If you want to use your progress bar simply to display status, then maybe you don't want a cancel button. However, we'll demonstrate how you could handle that in our code behind. So there's pretty much our XAML. We've got our 2 buttons that will be just on the UI that we can interact with, and then we have our border, which makes up our pseudo pop-up for our progress bar. Obviously, again, the progress bar could just be somewhere on your UI and be hidden until you needed it. So let's go to our code behind, and let's see what kind of things we're going to need in our code behind to interact with this. Alright, first of all, we're going to initiate a long-running process. So we'll create a method, and we'll just call this private void do long-running process, and we'll write something in here that would be our long-running process. So an easy way to do that is going to be to do thread, and we haven't added that namespace yet, but we will. Thread.sleep, and we'll make it sleep for 2 seconds. That's 2,000 milliseconds. And then after it sleeps, we'll do progress bar dot value equals, oops, not progress bar, what did we name that? I think we named that PRG, progress dot value equals, and we'll just say 0.5. That's about halfway across our progress bar. And then we'll sleep again, dot sleep 2000, another 2 seconds, and we'll do PRG progress dot value equals 1. And up here when we set it to half, let's also do text progress dot text equals, we'll say 50%. And we could calculate that and do a toString, but this will work. Text progress dot text equals 100%. Okay, so there's our long running process. So, oh, and let's go ahead and add, we're going to go up to our using statements. Let's do using system dot threading and using system dot windows dot threading, which we don't need yet, but we're going to come back, we will need that. Alright, so there's our begin, and in our begin we're simply going to say do long running process. In our button interact, why don't we just need to interact with the UI in some fashion. So why don't we come up here and we're going to do int counter equals 0. And we'll just come down here and we'll say this dot title equals counter plus plus dot toString. Okay, so that's going to increment counter and then convert it to a string and put it in the title bar. So then let's go with our cancel click, and for now our cancel click is not going to do anything. We'll come back and we'll add that later. So let's build this, see if we have any errors. Alright, we've got a successful build. Let's run it. Let's see what happens. Okay, so here if we click our interact with UI, you see that our title bar gets updated, and then if we click start long process and click on our button, nothing happens. Alright, and then it catches up and we finally see some interaction there. Notice our pop-up did not show up either. So let's take a look at why that happened. Well, first of all, when we do thread.sleep and we're running this on the same thread as our UI is running on, alright, notice we haven't spawned any other threads. We're saying current thread.sleep. It effectively blocks any interaction with the UI. So it's called a blocking thing. It will block the interaction with the UI, causing the UI not to update. So that's really what that means. So what we need to do is we need to run the do long running process on its own thread. That makes perfect sense. So the way that we would do that is to create a new thread with and have the thread run the do long running process. So we'll do new thread, and inside our new thread we'll say we're going to run a delegate, and we use the delegate. This is a delegate which consists of our do long running process. So the delegate is going to kick off our do long running process inside a new thread, and we want that thread to go ahead and start. So we're really just doing this all in one statement. We're saying create a new thread that's going to run the delegate that is going to kick off the do long running process, and we're going to start that thread. Alright, so this will cause the long running process to run on its own thread, and that way it won't block the UI, and we should be able to interact with the UI. Let's see what happens when we run this. Alright, so here's interact with UI. We'll kick off our long running process, and note we get an exception. And the exception occurs after the 2-second mark when we try to write to the user interface element. And if you see the exception, effectively it says the calling thread cannot access this object because a different thread owns it. Translation: when you are in one thread, that thread can't access the elements or the objects that are in another thread. And the progress bar is in the UI thread. That's in the main thread of your application. The do long running process is now running in its own thread. So here's where the real power comes in for doing this asynchronously, is we're going to use the dispatcher class to be able to do this. Alright, so let's take a look at how we do this. We need some way to be able to cross those thread boundaries. And this used to be a much more complicated thing to do, but now we've got to find a way to, from one thread, pass data to another thread to interact with the elements that are on that thread. Alright, and we do that using the dispatcher object. So let's begin, and let's just take it a step at a time. We're going to do dispatcher. Alright, so now within our dispatcher we're going to do begin invoke. Now the dispatcher.begin invoke, this doesn't spawn another thread. And that's one of the misconceptions that you'll see a lot, is people are confused about what the dispatcher.begin invoke does. The begin invoke says, I want to add something to the queue through the dispatcher to talk to another thread, to talk to the UI thread in particular. So we're effectively, when we say dispatcher.begin invoke, we're saying, hey, I'm running a thread. I need to talk to the UI thread, and I need to do something on the UI thread. Dispatcher, will you handle this for me? That's what dispatcher.begin invoke is going to do for us. So the first thing that we need to do is create a priority for our process. We're going to do that with the dispatcher priority dot. Alright, now you need to set the priority of your process. And remember that the whole goal of this is not to block the UI or not to cause the UI to freeze up. So we want to do this either on the background thread or the idle thread. So you could use background, you could use system.idle. We'll use the background. So we'll say, the priority of this is kind of a background process that we want this to happen in. Now we need to specify the actual delegate method. So we're going to create a delegate, and we're going to cast this to the send or post callback, and that's the type that we want to cast this delegate to in order to call this through the dispatcher to the UI thread. We're going to say delegate, and we're going to open a bracket so that we can actually specify this delegate in line. Now you could also specify a method name here, alright, but we're just going to do it in line. So we're going to do PRG progress dot, and this time we're going to call the set value method to set the value of a particular property, as opposed to accessing that property directly. And the property that we want to access is progress bar dot value property. And for the most part, when you're accessing a property this way, it's the property name followed by property. So we want to set the value. So what we're really looking for is value property. So we're going to set value of the value property, and we're going to set it to 0.5. So the exact same thing that we had done earlier, just done a little bit different. Alright, so there's our inline statement for our delegate that we're creating. And last but not least, we're going to pass no arguments. So we're going to just specify a null there, and we're going to end that call to dispatcher.begin invoke. Alright, now let's do another dispatcher.begin invoke, because we just handled this line. Now we're going to do our text progress.text equals 50%. So we're going to come in here. This is going to be our text progress.setValue. This changes to text block.text property, and the value that we want to set it to is 50%. That takes care of this. Now we'll do a couple more of these, except this time we'll set value property to 1 and the text property 100%. And then last but not least, we're going to call one more dispatcher.beginInvoke, and this one is going to go back. This is going to set our border progress. So border progress dot set value, and this is going to be border dot visibility property, and we're going to set it to visibility dot collapsed, so that we get rid of the window once the process has completed. Alright, so effectively the same thing, except this time we're using the dispatcher.beginInvoke to do our do long running process. So let's run this. Alright, we can interact with the UI. We're going to kick off our long running process, and we can still, notice, interact with our UI. Oh, we got a exception there. Let's take a look at that. And the reason why is this needs to be 1.0. It doesn't take an int. It takes, I believe it's a decimal value for that. So let's run that again. We're going to kick off our long running process. We can still interact with the window while our long running process is started. And the one thing that we need to do now is display our progress window. So we'll do that before we start our thread. We'll say border progress dot visibility equals visibility dot visible, and this pretty much brings us full circle. We can interact, yes, start a long running process. Here's our progress bar. We can still interact. We get the progress bar happening until we reach 100%. Progress bar goes away, and the whole time we were able to interact with our UI. And the last thing that we could do, because we said we would demonstrate this, is let's just create a Boolean, and we'll call this is canceled equals false. Is canceled, and we'll come down here, and when you click cancel, we're going to say this dot is canceled equals true, and come in here, and after our first break in the thread, normally what you would do is while you're doing your process you would check this value. So we'll just say if not is canceled, continue with all of this. And whether we're canceled or not, we still want to close our progress dialog, so we'll leave that there, and then we'll check it again after our second thread.sleep. So if not is canceled, alright, so now we'll start this up. We can interact. We'll start our long running process. We can click cancel, and the progress bar goes away after the first 2-second interval. So hopefully this demonstrates a very simple way that you can use a progress bar and kick off a long running process on its own thread, and then use dispatcher.beginInvoke to send information back to the UI thread to update that progress indication, so that you've got some idea of what's going on, how long it's going to take, and be able to talk to the UI thread without causing any kind of exceptions, because you can't cross that thread boundary.